Well, welcome. Today we're going to take a look at my local area network. I first got a LAN in about 20 years ago with 2 devices. I had a desktop PC at the time, and I had it hooked through a SMC barricade router to dial-up internet. I wanted to have the router there for purposes of using its firewall and keep me a little safer on the internet. Fast forward to today, and I have over 25 devices on it. On the screen is a block diagram of my LAN. You can see that I have several wireless devices which weren't available at that time. I have 2 smartphones, an iPad, 4 Squeezebox internet radios. I have an extensive number of things wired on there, in addition to 2 desktops, a laptop, another laptop running Linux, a FreeNAS server, and a Windows Home server. I also have my printer, several media devices, an Apple TV, a Roku TV, and a Blu-ray player. Also a Roku sound bridge to provide audio. And our phone system uses Vonage, which has a little device on it. There are also 2 Raspberry Pis. One of them I'm using as a DNS server, and we'll go into that in more detail. There are so many devices that I've had to get some switches to provide enough wired connections on there. Okay, let's move along here. I mentioned a printer. It's an HP printer, which not only prints but copies, scans, faxes, and more. It's directly wired to the network, and it's available from any of the wired devices. And also, the printer has wireless capabilities so that smartphones and the iPad can directly print to it. Back 20 years ago, I only had a printer that went through one computer, and while you could share that, that computer had to be on in order to make the printer available to anybody else. The printer, of course, has its own embedded web server. This is how you access it, and you can do everything from that if you wanted to: scanning, faxing, setups, check cartridges, and also update its firmware. I mentioned that we have Vonage. This is the Vonage device. It's they buy it from Groundstream. It's about 3 inches square. It's about the size of a Apple TV, and that has a phone jack in the back, and that then goes to our Panasonic phone system, which has several wired extensions. And of course, this has a web page that you can use to check its condition and make some setting changes if you want. You'll notice that the user ID is kind of blurred out here. That's also the case on the network diagram that I had in the beginning. I've tried to blot out personal identification on there. So you will have, in the case of the Vonage, you would have your phone number on there. I've chosen to mask that for us. The Roku sound bridge provides audio from either my music on my server or any of the internet radio stations, and there are many available. That goes into our audio system and then can go around to the various speakers. And of course, that has a web page to do some setup and status checking on there. This is the Windows Home Server web access, and I can use that to then remote log into any of my Windows 10 computers, access my pictures, music, and videos, and they're also shared so that I can get those remotely. The router is set up to pass outside web accesses through to this, and so I can really get to access this from anywhere over the internet. I also have a FreeNAS server that I'm going to use to replace the Windows Home server. This is in the process of being set up, but it will have the same capabilities. Both of them do backups for all my Windows machines, in addition to providing local storage of all of my files. My Windows machines have almost no storage on them. And in addition to the storage, which is then shared, I also can use the remote access to remote into them. This is the Apple TV box. Again, it's only about 3 inches square. And this is the Roku TV box. And this is the Blu-ray player. They all provide audio and video to our entertainment system. And they also can access the internet to provide that content. The Squeezebox radios, of which we have 4, are all wirelessly connected. They'll provide access to my music. I have about 9,000 tracks on the server, and they also provide access to any internet radio station. So we listen to New York radio, Folk Alley, San Francisco radio, et cetera, et cetera. My wife has an iPad. She's connected wirelessly. She has an iPhone, and I have a Samsung Android phone that have access through the internet via wireless connection. This is one of the network switches that I have. I have 3 8-port switches. This, for example, lets me run one network cable into the entertainment system area and then provide access from that one cable onto the Apple TV, Roku TV, Roku Squeezebox, and Roku SoundBridge, as well as the Blu-ray player. This is where it all comes in from Comcast. We used to have Verizon, and when we recently moved, Verizon doesn't service our community, and so I have Comcast Xfinity. This is the modem. It will do up to 6.8 gigabits per second over DOCSIS 3.1. I do not have it set up access to that speed. I do have 250 megabits per second. It supports IP version 6 as well as IP version 4, and we'll talk about that later. And of course, it has its own web page that you can use for status checks and making setting changes. This is the status output, and you can see that there are a lot of cable channels available that get bonded together to run the higher speed. But this is my ASUS router. It's an RT AC86U that I bought when we moved here. It does so much more than that Barricade router that I started with. And most of our talk today will be on screenshots of the various facilities that the router provides. So this is the thing that you would see when you accessed it. And it has a overview of everything. Tells us that we're connected to the internet. It gives me my WAN address, and also that the dynamic DNS is in service. The wireless is up and running, and it's using WPA. On the right side, there are different boxes that I can check to see what's going on with both the 2.4 gigahertz band and the 5 gigahertz band. It shows the network name, the encryption method, and the WPA key is hidden, but we can get access to that too. Along In the center, going a little bit lower, there's a list of the clients that are currently connected, and how the AI mesh is connected. We'll talk about that in a minute. It also has two USB connections, and we can use that for various capabilities. I am not using that now, but for example, you can hook a USB drive up there, hard drive up there, and make that available to all the machines and devices on your network. If I expand that view of the client list, you see something like this. It has an icon for the devices as well as the client name and its IP addresses. It tells us whether we've assigned it statically or manually. It gives the MAC address, which is the media access connection address. The next column, interface, shows whether it's wired or wireless, and if it's wireless, whether it's on 2.4 gigahertz or 5. As you can see, the iPad is the only one that's on the 5 gigahertz band. The squeeze boxes are all on the 2.4 gigahertz band. It also shows our transmit and receive rate, as well as the how long we've been accessing it. We could have this separated by interface, and we can also look at it by just a single client name if we wanted to. Going back to the second tab on the left, which is shown as guest network, you can set up to 3 guest networks on each of those 2 wireless bands, which will let visitors to your home use your wireless network without giving them full access. You can decide whether you want them to only be able to go out to the internet through your internet connection, or whether you would like to have them be able to access devices on your local area network. They can be time limited, and it's very secure way to let people that don't live in your home get access for limited purposes and for limited time. AI protection is an arrangement that ASUS has with Trend Micro, which will monitor your transactions to look for malicious sites and various things that Trend Micro can look for. It also gives you access to parental controls for time scheduling and filtering apps. I don't make use of that. You need to set up an account with Trend Micro as well as an account with ASUS to use it. If I had children, it might be a useful thing to limit their time as well as limit where they can go. The next tab, Adaptive QoS. QoS stands for Quality of Service. It can allocate more bandwidth to certain applications, certain devices. For example, if you're a gamer, that would probably be the most useful use for doing that. I do not have any QoS set up, but you can use this as a monitor of who's using your bandwidth. As at the time I took this screenshot, you can see Berman, which is one of my desktops, was using a tiny bit. One of the squeeze boxes was running using a tiny bit, but overall, at the time I took the screenshot, I was using very little bandwidth. I go to the next tab over from Bandwidth Monitor, which is QoS. You can see that we can turn on QoS, and then you can set various filters here to make it be only for certain devices, certain applications, certain types of packets that you're sending back and forth. Web history is the next one, and this would give you, if you have it turned on, and I turned this on just for this example, it'll show you when a device accessed the internet, which one it was, either by MAC address, or if it knows the name, shows the name, and then the domain name that it accessed. So you could see when I took this screenshot, my wife had been using something on the iPhone, and I can filter that by using this drop-down that currently says all clients. I can change it to a single client and see who's doing what. Ordinarily, I have this off, but it would be a useful troubleshooting device if you needed to. Traffic Analyzer is also a longer page. I didn't scroll all the way down, but you can use this to identify which devices are using most of your bandwidth, and it shows by default the top 5. At this time, the Roku 3, Berman, which is one of the desktops, an iPhone, an iPad, and one of the squeeze boxes was using most of it. It'll show you which apps it was using it, that bandwidth, and there's a pie chart in the bottom left. In the top middle, there's a chart over time, and you can set that either for all clients the way it is now, or pick a particular client. It shows you how much traffic you used overall. If you have a bandwidth limited account, that might be useful. You can also switch between looking at clients and looking at apps. And again, this would probably be most useful if you were doing troubleshooting for some reason. The next tab is a traffic monitor, and you can use it to select between wired and wireless. It will show you how much you're currently using, the average, how much you've used all the time, and what your maximum usage was. And you can filter that down by client and so on. Game Boost is an option on this particular router. I'm not a gamer, and so you see that I have not turned these on or configured them. If you do have a gamer in the house, that probably would be pretty useful. USB applications I mentioned before. You can use AI Disk and set that up to share files on a USB hard drive throughout the internet. So that would let somebody access it from outside of your home, and there are controls on that to keep it from being wide open to everybody. Media services you can set up to get to again, iTunes and FTP and so on to make media files available throughout. If you have a printer that is only, for example, USB compatible, does not have a built-in network connection, you could plug that in here and then set it up by using either their Easy Printer software or set it up as an LPR device. LPR is common in the Linux world, and then have that as available as a network printer on your network, and you would not have to chain that down to one particular desktop having to be turned on and configured properly to get it. 4G, if you had a wireless dongle that connected to a wireless service and then had a USB output available, you could hook it there. Or if you had a Android phone, you could run a USB cable from that into this and then make that available as your path out to the internet, or it can be an alternate path. I don't know what wireless speed you have, but it's probably not up to like my 250 megabits per second. Time Machine is a Apple function which does continuous backups. Again, if you had a USB hard drive on there, you could configure this as your Time Machine target. Download Master is a way to set up a download manager on this, which could download files over the internet and keep it here on the router until it was completed, and then it would make it available to your other computers on your network. AI Cloud is a way for you to access your data from anywhere, and I had mentioned this previously, and what you would need to do is have a dynamic DNS available, and we'll talk about that in a minute, to let you get access back to your home network, and then you can access that USB device. There's other modes that you can use, Smart Access and Smart Sync. I do not use that. I may at some point. This is the Smart Sync connection. We don't have a disk connected. We have to set up a disk first and then set up an account to let people have access to it. Sync server, we have to enable AI Cloud first. Settings, this is to set up the password access to it, and it would need a web access and a content streaming port. This port 443 is also used for HTTPS. My Windows Home Server uses that port right now. I'd have to change that to a different port if I ever wanted to use this. And then there's a log available for the activities on AI Cloud. Nothing shows up because I'm not using it. I'll mention at the top of this, you can see a button to log out, to disconnect from this, a reboot button, which would let you reboot your router. You can choose the language. I have it set up for English. It tells us what mode we're in. We're setting it, have it set as a wireless router. There are some other modes, and we'll talk about that when we get to see what settings we can change and turn it into. It shows the current firmware version. It has a feature to go out and look for new firmware and then update it. As you can see, there's a lot of functions on this router, and so there have been 3 or 4 firmware version upgrades since I've started using it. The SSIDs are the names of the wireless networks for both 2.4 and 5 gigahertz bands. I have that blurred out here. And then there's some other icons there. We're going to move down to the bottom in advanced settings on the bottom left. And this is where you would set up the wireless configuration. So right now, the top switch is set to off for enable Smart Connect. Smart Connect is a way for your devices to try to connect wirelessly to whichever band is the most efficient for them at the time, considering speeds and noise and so on. Apparently that's a little over-optimistic, and people often online recommend turning that off. I wanted to have it off just so I could configure a particular device to a particular band. We're showing the 2.4 gigahertz setup right now. There's a drop down there at band, and I'll bring my arrow over there, and we could pull this down and change to the 5 gigahertz band. The network ID is set right here. You can change the wireless mode. You can choose to hide the SSID. You can set up how much bandwidth for each one, which channel out of 13. There's really only 3 that you can use, 1, 6, and 11. The authentication method and the encryption method, this is where you would enter the key or the password to get onto your wireless network. And there's some other options here too. If we go to the next slide here, this is on the 5 gigahertz band. And again, there are settings for, again, with the network name and the key, and then some other ones. Most of these are just set to the default values. WPS is a way to easily connect to a wireless network. It often has problems for different devices. It's easier for me to just use it directly. I have this disabled right here. You can turn it on if you want, and you have to specify a PIN code. This is the current one that's in there. Again, it's configured, but I don't have it enabled. There have been some hacks using WPS, which is another reason to leave it off. WDS is a wireless distribution system. It lets you connect to a wireless access point, which would make you be able to use that to get access to the internet. So if you were in a situation where there was a wireless in your unit or to your unit, you could set this up to access that wireless system and then use that rather than getting your own internet access. Again, there are configurations for this, which band, what mode, and so on. Again, I don't use this, so I do not have it configured. You can set up a MAC filter on here. MAC stands for Media Access Control, and that is essentially a serial number for each device that connects to a network. They are unique, supposedly unique in the world, and you can set up this MAC filter so only devices with a particular MAC address can connect to your network. So, for example, if somebody wanders by and tries to connect to your wireless network, even if they had the password, they would not get out because they would not have a MAC address that would be in this table. Unfortunately, it's easy to clone MAC addresses. It's easy for them to snoop on your wireless network, find a MAC address that's enabled, and then use that to get in. So I don't use MAC filtering. Some people online will recommend that as a security measure, as well as hiding your SSID. I've chosen not to use it. The next tab is for radius. It's really only useful for an enterprise system where there's a server that gives out access keys. Again, I don't use that. The professional tab lets us set any number of arcane settings in there. It's probably best to leave these alone, and I have not changed any of them. Again, with roaming block lists, this is really only used in AI mesh mode, and we haven't talked about that yet, but we will. All right, moving down the left-hand side to our LAN settings, our local area network. This is what's inside the router. So this is the point where you would set up your router's LAN address. Anything on your device network every device will have to access your router, and they will have to know this address. You can see there's two parameters here, the address and the subnet mask. The subnet mask defines which bits share between the network address and the device address. So let's look at internet addresses for a minute. This has both IP version 4 and IP version 6 in there. You can see that on IP version 4, which is what we're looking at now, it's a 32-bit number. The 32-bit number lets us uniquely specify about 4.3 billion addresses, which seems like a lot. However, the world has run out of IP version 4 addresses. There's ways around it, one of which is IP version 6. We'll talk about that in a minute. But that 32-bit number is usually represented by this dotted decimal notation. It breaks it up into 4 8-bit numbers and then represents each 8-bit number as a decimal number. There's also a CIDR, which stands for Classless Internet Domain Routing method, and this would be what that would look like. We'll talk more about IP version 6, but you can see the advantage of that. Instead of a 32-bit number, it uses a 128-bit number, which gives us 340 and an awful lot of digits after that. We will never run out of IP version 6 addresses, and they are represented in hex notation. Hex digits represent 4 bits, and so these are groups of 4 hex characters represents 16 bits, and we have um, 8 um, 8 of those groupings here to represent the 128 bits of the IP version 6 number. All right, so IP version 6, this is what a packet looks like. Every packet has the source IP version 4 address and the destination IP version 4 address. This is where those 32 bits show up in there. And we will look at that. I talked about breaking it up into 4 groups of 8 bits. And each group of 8 bits gets turned into a decimal number. And once you have that, you can then look at the figure out what the subnet mask should be. Now, the 32 bits are broken up by network number and device number. For every bit in the subnet mask that's on, that says that's part of the network address. So the subnet mask that's shown here, 255.255.255.0, says that the last 8 bits are used to distinguish a device on a particular local area network, and that local area network will have 24 bits in it. So this 24-bit address is 192.168.2, and every device on that network will have to have these as the first 3 pieces of the IP version 4 address. The last piece we need to know to get access to it is the default gateway. Usually by convention, the router or the gateway is given address 1. And so if you have to set up a device statically, and you may have had to do this in your past or your current devices, it may look like this. You set it up for static and you need to put in the address, the subnet mask, and the gateway. That's all you need to get access through your router to the internet. Now, that's a pain in the neck if you have a lot of devices, and I do have a lot of devices. What you would do then is click this that says DHCP. DHCP stands for Dynamic Host Configuration Protocol. That needs a DHCP server. The router has a DHCP server built in. We're going to look at that in a minute. Before we leave the screen, you also need to have access to a domain name server, a DNS server. If you specify it manually, you're going to have to put the address of a DNS server in here. They recommend you give 2. This one has 2 specified. The other choice would be to click dynamic here, and that is usually part of the DHCP server's response. All right. Address ranges. There are 3 reserved addresses that can be used for our private LANs. One of them would be anything that starts with 10. And if we were using this as our address, our subnet mask would be 255.0.0.0, which would say anything with 255 is anything with 10 in those top 8 bits would be on our local area network. And that would give us 24 bits to specify a device on our local area network. That's a lot of devices. The second address block is 172.16.0.0. The subnet mask for this would be 255.255.0.0. That says every device on your network would need to start with 172.16, and that would give us 16 bits, or about 65,000 devices on your network. That's a lot. Mostly you will see addresses in this range, 192.168.something.0. In our case, in the previous screen, we saw 192.168.1.0. In my case, it's 192.168.15.0. So you can specify that. And what that will let us do is give 256 devices. Now, you can't use 0 and you can't use 255. So it really gives us 254 devices. And the subnet mask should be 255.255.255.0. And that says anything with 192.168.15 is on my local area network. And anything else is somewhere else, and we'll have to go through the router to get to it. This table has the other reserved blocks in there. We won't be using that except for the loopback addresses, which all start with 127, and that's a way to get to your own machine. All right, I have a command prompt output shown here, and I've typed in ipconfig, which is a built-in Windows command which shows you how your adapter is set up. It's showing us right now that on this particular machine, it has the address 192.168.15.104. And the subnet mask is 255.255.255.0. And the default gateway for IP version 4 is 192.168.15.1. Those all came from DHCP response, which in turn came from the router. This is one of my desktop units, and this says that to get to any device with these top 8 bits matching this, we can get to it directly. Otherwise, we're going to have to go through the router. You'll see some IPv4 version 6 addresses here. I do have IP version 6 configured on my network, and it's using that the majority of the time. All right, back to the router. This is a tab for the DHCP server. You can see here I have it enabled. When you enable it, you have to give it a pool of addresses. We're saying we can give out addresses .2 up through .199. And the lead time is in seconds. There are 86,400 seconds in a day. This says if somebody gets an address from us, they can keep it from a day. I'm also going to tell them the DNS server that I would like them to use, which is .6. By default, it also tells it to use the router's address of .1. Again, the router has a DNS server built into it. So this is what will go out to clients who ask for an address on the network. You can manually assign addresses, and let's move down to that. These are often called DHCP reservations. I've taken, for each of my devices, I've entered, and you can see, if I wanted to add a new one, I would do it right up here. Put in the MAC address, the IP address you'd like them to be given. So for example, for Dino, I put in its MAC address, which you have to learn from the device. I'd say if Dino or a device with this MAC address gets on the network and says, hey, can I play here? I need an IP address. The router is going to give it .106. This combines the best of everything, in my opinion, because it gives you a specific address for a device. It will never change. So it's like a static address. However, the device does not have to be configured. I only have to configure it at the router. So here's one of my desktop units that we saw before, .104. This is its MAC address. Whenever it connects to my network, the router gives out .104. Some devices, you need to have a fixed address on. So for example, FreeNAS is a server and needs to have a fixed address. This is a way to give it a fixed address on my network without specifying it in the server itself. The same is true for one of my Raspberry Pis, which is a DNS server. It's also true for my Windows Home server. All right, I'm going to move along. This is the output from a program called DHCP test. What this does is it pretends to be a new device on your network. I think what it does is it makes up a MAC address here. So it can't be something the router has already seen, or else it would already know what to do with it. And it says, I'm new here, can I play? What can you tell me? Here is the response from it. And you can see here it came back from .1. .1 is my router. It came back from the DHCP server that's on there. It says, what you should use is you should use .117 right here. .117 is not assigned to any other device on my network. If you use that device, use a subnet mask of 255.255.255.0. Use this as the router. Use these as the DNS addresses. And if you need to send a broadcast, use .255. So a broadcast is a message that a device might send out to everyone on a network. And for example, this is how you get to the DHCP server. You don't know where it is when you hook into the network, so you use a broadcast message. It actually sends it out to 255.255.255.255, which means go to everybody on there. This is the lease time, 86,400. The renewal time is half of that. It says in half a day you can try to renew it again. It'll rebind it in 75,600 seconds, which is 21 hours. But otherwise, if you want to just stay connected, you'll always get the same response here. However, if you disconnect and come back in, you may get a different answer. So this is a DHCP test. Let me check to see what sort of answers it was giving. And if you notice, these are all IP version 4. I need to go through and find out what it does on IP version 6. So, all right, back to the router. You can load routing rules into your router. This says that if you say you want to get to a particular address on the internet, you should always use this particular interface. Now, I only have one interface on my router, so I don't have this enabled. If you had two interfaces, let's suppose you were really rich and you wanted to have constant access and you hooked up to Comcast and Verizon, you could have both of those available. You could specify which networks you should go to and use which access ISP. So as I said, I only have one way out, and so I don't need the routing function, but it's there if you want to use it. IPTV, I'm not familiar with at all. I guess special settings you have to put together if you want to use it, and again, I don't use it. So, switch control, jumbo frames are a way to use packets that are larger than the initial specifications. Some devices do not play well with jumbo frames. I have this disabled. If all of your devices work fine with jumbo frames. You could enable it and then get better performance. We're going to jump down now to WAN settings. So WAN settings are the settings for accessing the internet on the ISP side of the router. We are going to set this for automatic IP, which means basically the router now sends a DHCP request out to Comcast and checks to see what comes back. So we have WAN enabled. We have NAT enabled. NAT is network address translation. It's a way to share the multiple IP addresses of our devices internal to our network with the one external IP address that Comcast makes available to us. We can use either the DNS servers that Comcast wants us to use, and if I click yes here, that's what would happen. Or you can specify your own. Now, the two that I put in here came from OpenDNS. OpenDNS, we're going to talk about in a minute. It gives you some extra features that the Comcast servers would not give you. It also keeps Comcast from knowing exactly what I'm trying to go to, but of course it has other ways of figuring that out. So this is of limited use, but it's useful nonetheless. Your ISP may tell you to do certain things in this area. Comcast doesn't require that. If you had an extra access, like I mentioned with Verizon and Comcast, or perhaps over your wireless network, you could enable a dual WAN, and you could tell where to get the primary and then where to get the secondary from. And you can specify whether that secondary access is to do load balancing, to even it out, or whether you want to look for the maximum bandwidth, or minimize your response time, or maybe if you have a limited bandwidth on one or the other, you could switch over after it gets to a certain point. As I said, this is a capability the router has. I don't use it. Port triggering and port forwarding are two ways to get access to something inside your network from the internet at large. So I don't use port triggering. I do use port forwarding, and if you look down here, well, I've turned it on, and I said if anything comes in to my WAN address on port 80 or port 443, I want to route those along to port 80 and port 443 on this particular IP address. This address is my Windows Home server, and this is how I get remote access to my music, my remote desktop connections, and so on. You can put in other ports in there if you wanted, other features in there if you wanted to set up an FTP server, if you wanted to set up a DNS server, if you wanted to put any number of things, you could do that, maybe a gaming server. So this is pretty important to me, and I have it set up, and it works great. DMZ lets you essentially take one machine and make it completely exposed to the internet. That's kind of hard to imagine, and I don't recommend it. There are some features that we need to be able to get back to our system from externally, and remember that I don't know what address I get from Comcast. They can give me a different address at will, and if I told somebody else you can get me at this particular IP address, that may change over time. So what we need is a name that would translate to that IP address, and because it changes, you need to use a dynamic domain name system. So as you can see, I've enabled the DDNS client. This is another feature running in the router. You can see this router has a lot of capabilities. What happens is the router monitors the address that it is currently getting from Comcast. Whenever it changes, it sends a particular request out to the server that I specify using the parameters that I specify. That server then keeps track of this new address and lets me access my system by getting a particular name that they reserve for me from another machine. So this maybe sounds complicated, but the Windows Home Server, for example, to get that access to that from an outside device, I would have to have a URL to get to it. My particular one is a name.homeserver.com. Now, that particular system is taken care of by Microsoft, but my FreeNAS server, for example, does not have that feature, so I need to get another system. There are multiple systems which can provide DDNS services. The hitch with that is the router can only access one. And DNS-O-Matic is a way for you to tell one system, and if you set up an account there, you can set up multiple target systems. So the flow here is Comcast gives the router a new IP address. The router notices it. It tells DNS-O-Matic, hey, we got a new address here. DNS-O-Matic tells 3 other people, hey, we got a new address here, and then everything works fine. So these are the parameters I need to tell DNS-O-Matic. This is the host name. All is just what you need to use whenever you have more than one system at DNS-O-Matic. You need to give your DNS-O-Matic account name and your password, and then apply, and then that will happen. Now, let's look at what happens at DNS-O-Matic. DNS-O-Matic, you have an account. On the account, you can set up your services. I have 3 set up. Number 1 is at Change IP, 1 is at No IP, 1 is at OpenDNS. Change IP and No IP are both dynamic DNS services. OpenDNS is not quite the same. OpenDNS we'll talk about, but it will filter your DNS requests to get rid of places that you don't want to go to. So it doesn't give you an opportunity to resolve your particular IP address, whereas the other 2 do. This screen at DNS-O-Matic will show us the current status. It shows the current IP address that it's aware of, reporting to these 3 services, when they did it, and you can go back and look at the history of it. Now, you can see they all were updated on when I took the screenshot on April the 15th. So that means that it was successful at the same time that it updated. All right, let's look at Change IP first. ChangeIP.com lets you set up a dynamic domain name. And I have my domain name here at changeip.changeip.net. If I try to resolve that name .changeip.net, it's going to come back and say in a web browser, it's going to come back to 69.mycurrentaddress from any place in the world. And that will happen soon after Comcast has changed my IP address. Change IP is free. I recommend it. It's easy to use. They have premium services, but they just will keep the free one on there for whatever you want. No IP is also free. However, you have to update it. You have to re-access it every 30 days. Now, this is not manually going in and updating the IP address, because the router will do that. However, it will throw away your name if you don't go through and log in and just say, hey, keep me in the system every once a month. But it's similar to change IP. You have a name.noip.org. And when you set these up, they have other choices of top-level domains and second-level domains you can use. Doesn't really matter. Again, if I tried to resolve this one from anywhere in the world on a web browser, it would come back with my current IP address and then get me to my local network. The third place is OpenDNS. Again, it's free for up to maybe 3 networks, maybe 1 network. This is my network name, and again, it records that with the current IP address. Now, the reason it needs to do that is it needs to know what your network address is, so that if it gets a DNS request from somebody on your network, it needs to know what kind of filtering is in place. And it keeps various logs. This is all of your activity, domain names, unique IP addresses. Now we only have 1, right? So that's always going to be 1. It shows you what request type, IP version 4, IP version 6, the domains that you're going to in order of requests. Here in the settings, you can set up your filtering. Now, at the top, you can set high filtering, and it will skim off any request that you make for something that they've judged to be adult-related, illegal, social networking, video sharing, and general time wasters. You could select that, or moderate, or low, which is only pornography, none, which is nothing blocked, or custom. If you select custom, they give you 56 choices, I think, that you can select from. So if I said custom right now and enabled that, it would protect me from lingerie, sexuality, webmail, tasteless, proxy, nudity, dating, adware, and so on, but not government, humor, movies, web spam, search engines, travel, and so on. So it's a way to try to help keep you safe. But as you saw, I had it set up for no filtering because I have other ways to do that. All right, so so much for dynamic DNS. NAT pass-through, I have all the defaults selected here. I'm not really sure why you would want to do that. Maybe if you had a virtual private network set up, and we'll talk about VPNs soon too. Let's look at IP version 6. IP version 6 is available in the router. I already mentioned that it was available from Comcast. Many ISPs don't have it available, for example, Verizon. To enable it inside your network, you can use this pull-down network, and Comcast, these are the settings: native, DHCP connection is enabled there. This is the address that it was given, prefix. This is the server it was given. This is the IP version 6 address of OpenDNS DNS server. And again, that's all you need to do, and then it'll be available inside your network. Okay, VPNs. Well, before we get there, this is DynV6. This is a way to get an IP version 6 resolution for an IP version 6 address. So again, it's a free system. You can just set it up you make an account and then give it it will give you this domain name, and then it will return IP versions 4 and 6 addresses whenever you do that. Now the kicker with this is the router will not update this automatically. OpenDNS and DNS-O-Matic will not update this automatically. You'd have to do this manually. I don't really use this yet. I'm just investigating it right now. All right, down to VPNs. VPN is virtual private network. VPN is a way to get safe access to your network from someplace in the world. If you're in Starbucks or McDonald's or someplace, or Giant using their Wi-Fi, this prohibits anybody from snooping on your traffic because it keeps it all encrypted from your machine back through to your network. So you can see I have it enabled, set up for general. You need to set up a username and a password. I have it set up here. It has 3 versions: point-to-point tunneling protocol and IPsec VPN. I'm using OpenVPN, which is a open source implementation of this. There's no charge to use it. You may have looked into VPN and you see that there's a fee for using most OpenVPN servers. This does not use anybody else's OpenVPN, so that they're not going to snoop on you. This is going to go directly from your device, whatever it is, and they have clients for Android, smartphone, and Windows, and Mac, and Linux, wherever you are, back to your local area network. Now, the next screen is for an OpenVPN client. Well, we didn't get there yet. Let's back up. These are how you would get the client to put on your machine. So if you have an Android phone, you would go to the Google Play Store. This is your VPN client that you would download and install, and then use a configuration file that's available, which I'll show you. If you have an iPhone, you can go to the App Store. You download and install OpenVPN Connect. Again, it's free. This tells you how to set it up on Windows. Again, it's free and it just shows up there. To talk about how it works, here is my laptop. Here's the wireless network at Giant. If there's a snooper there, he can hook up too and then see my transactions. The wireless router at Giant goes through other devices and then goes back to the internet and goes back to where I'm going, maybe my bank. If I have a VPN set up, my laptop will get encrypted. All those packets will get encrypted to get to the wireless router. It'll still be encrypted going to their other devices. It'll be encrypted going through the internet and back to my router. Once it gets to my router, it'll decrypt it and then put it on my LAN. And if it's headed to my bank, it'll then come out of my router and go to my bank. Now, this is not encrypted with the VPN, but it probably will be HTTPS, and so it's also secure. But the point is, using a VPN will make remote access through a wireless network as secure as doing it in your own home. All right, now we get to the VPN client. VPN client means that the router would become a client to a VPN service, which you might pay for. This would be a way for you to use an encrypted packets all the way from your WAN connection to the VPN service. So you could pay for a VPN service, and then Comcast or Verizon or whatever your ISP is would not be able to see what you're doing and where you're going and so on. Now, VPN does extract a performance penalty, so you probably wouldn't want to do that. There's also a cost for most of them, so it's probably overkill, but the router has it available and you could use it if you want to. There's a firewall built into the router. I have that enabled. You can make inbound firewall rules if you need to put something in there that the firewall existing doesn't protect against. It works on IP version 6 as well as IP version 4. You can specify various other things. Denial of service protection, I don't have available. I haven't had that problem. But you can specify servers that you want to allow access to in addition to any other rules that you have. If you want to check if your firewall is working, you can go to Shields Up, which is at Gibson Research, grc.com. It'll tell you what your WAN address is. It'll look at all the common ports. And here we'll see that it can't see any access except for port 80 and port 443. If you remember, we opened port 80 and port 443 to my Windows Home server, and so this is to be expected. If I didn't have these open, I couldn't get to my Windows Home server. But FTP, Telnet, POP3, and so on, they're all shut. And you can look at actually every port and see which, if any, are open. But this is a good report, even though it's marked failed. This is exactly what I want to see. All right, URL filter. You can specify URLs that you want to block, and it will block accesses to particular URLs. I don't have anything specified, but if you say, well, we never want to go to umpty-ump, you could put it in here. I have some other ways to do the same thing. Keyword filters, you can specify keywords in here, and it will not give you access to them. So as long as they're not encrypted, not using HTTPS, what it will do is it will get the page returned, it will analyze the page, and if any of your keywords are in there, it won't show it to the client. You could put Kardashian in there, for example, and nobody on your network will be able to see the latest Kardashian news. If you have it enabled, I don't have it enabled. Network services filter. This is a way to block certain services. You can specify particular applications, and you can do it by time. You can do it by day, weekdays, or weekends, and use a particular hour and minute to begin and end. Again, that's maybe most useful if you have kids. All right, we're down to administration, operation mode. This is where you would tell your router what mode to work in. The default is wireless router mode. That's where we have it set here. AI mesh mode lets you access, have access to a larger home that maybe your wireless network would not reach. So additional units would connect to the first unit and then provide a new wireless network at that point. You can also use it in repeater mode or bridge mode. This might be, again, if you have access to another wireless network and you just want to repeat that inside for your devices to use. You can also, well, do a lot of things. I have a relatively small enough unit right now that I don't need to worry about that, and I don't need to use worry about repeaters or AI net mesh. System, this is where you would change access to this web page by changing the login name or the password. You can set the time zone here and when daylight saving time starts and ends. It sets its own time by using this NTP server. You can put a different time server in there. There are various ones. This pool.ntp.org uses a large number so that one is always available. Again, lots of settings here. Firmware, this tells what the current version is. You can either let it do its automatic check to see whether there's a new version, or you can say, check for it right now. If there is, you can manually do the update, or you can download the firmware from somewhere else and then manually update it. Again, it's a pretty active system, and it should make you feel good that it's constantly being updated. Settings, all these settings that we were talking about, you can restore to the factory defaults. If you really screw it up, you can save the current settings someplace on your machine or any machine. You can restore the settings from previous set. So if you were going to do some investigation of, for example, AI Cloud, maybe you'd want to save them, and if it didn't work out, just restore them back. It's a good idea to save them. There are a lot of settings. Feedback is a way to tell ASUS how you like using the router and if there's any suggestions you have. Privacy, there's the privacy policy for using Trend Micro as well as your ASUS account. And there's also some logs that are available, quite a few here. General log, it gives you the time of date, what happened, and what's going on. You can do some filtering if you need to. There's a separate log for the wireless system. It shows you who's connected, when they connected, what their signal looks like, what channel you're using. DHCP leases, this is who has, again, connected and what address they're using. Now, of course, this is going to match what we specified in our DHCP reservation listed. It also tells you when it's going to expire. In case you have to go through and make a change, for example, you might want to expire it earlier and tell it to get a new address. IP version 6, again, like the previous screen, it shows you who's hooked up, what their MAC address is, what their current IP version 6 address is. If we were using a routing table, this would show the ones you've added. Otherwise, it's going to show you the default ones. This one would show the default setup, and the default setup is to basically go out to Comcast, which is right here. The mask says basically send everything out there that's not on our local network. There's a separate routing table for IP version 6. If there's anything, this says if there's anything on our local area here, send it out to the local area network. Port forwarding, this is our log for that, and it would show us any action on there. And finally, connections. It's showing what our network address translation addresses are and where they hook to. So these are the current addresses in use. So 104 is my main desktop. This last number is the port number, and this is the IP address and port of where it's going. So this should show you everything that's currently in use. If there's something nasty that's going on, you could use this to track it down. There are some tools that are available here. We could use ping, we could use traceroute. You can use this to troubleshoot. We could put in like google.com and try 5 packets, diagnose, and it would show us trying to access Google from the router. So if you have trouble getting someplace from your device, you can try it from the router and see if it's successful there. If it's not successful with the router, it's something external. If the router can do it, your device can't, it's probably something internal to your network. Netstat will show us basically everything that's going on in your network. It's a name of a program that some of you may be used to using on a Windows or a Linux machine. Wake on LAN is a way to wake up a device. If you have, you can specify a particular device that you would like to hibernate or put in sleep mode, but wake up at a particular time. You can do it by specifying this and then have the device tell it basically to wake up. So it's not on unless you wake it up. Smart Connect rule, I briefly mentioned this when we are talking about the wireless connections. You can specify how you want to switch somebody between 2.4 and 5 gigahertz bands. There's a lot of settings you can do here. Again, it's maybe a little ambitious, and what I've seen on the internet is it often doesn't work too well. But I don't have that many devices anyway, and I'm content to use it the way I'm currently using it. All right, some of the devices on here. This is my Raspberry Pi. This is the Pi itself. It fits in this case. In addition to the Pi, you need a SD card. This is 32 gigabytes. It fits in the bottom side of right here. We don't have this switch. This is just a general thing. I didn't buy their Cana kit, but that comes with heat sinks that you could put on these two chips. You do need a power adapter right here, which plugs into this. And this is the connector that you would use for the display if you had a display on. These are 4 USB connections if you need to use it. And this is the network hardwired connection. So I have a hardwired connection to it. It does not have a monitor or a keyboard or a mouse. I did need to have those there to set it up. And what's running on this? Pi-hole. Pi-hole is a DNS server which will do ad blocks. It blocks 111,000 domains. It's currently blocking about a quarter of all the requests. It shows you, if you log in, a log of the last day by time, as well as by clients over time. And if we move down the page a little bit, it shows us which domains we're finding that we're allowed to get to, which domains that we're blocking, which clients ask for those domains, and which clients ask for the blocked domains. It also will show us how we're connected and some stats on the Raspberry Pi itself. If we look at the DNS settings here, at this point I was using another DNS server on the Raspberry Pi called Unbound. We'll talk about that in a minute for both IP version 4 and IP version 6. But you don't have to use that. You can say use any of these well-known public DNS servers. So you might recognize OpenDNS here. We already talked about that. If you were not using your own, you could specify OpenDNS. and use its features. Now, the reason I'm using Unbound is that it's a private validating recursive caching DNS resolver, which means it goes back to, if I ask for google.com, it'll go back to the root servers and find out who knows about .coms. Then it'll go to that server and says, well, who knows about Google? And then finally, it'll go to that server to find the IP address. And this keeps your ISPs and Google and OpenDNS and whatever from finding out which URL, which domains you actually go to, and then selling your information. The last screen here, almost the last screen here, is a shot of ASUS WRT Merlin, which is a custom firmware available for my router. This is an interesting site which takes the open source software that's available on my router and makes some extra features on there, but not really change it too much. So if you wanted to have some of these extra features, and you can go to this URL and look it up. If you think that those would be useful, you can put those on your ASUS router and then get those on top of the features that ASUS already puts in there. The very last screen is a list of what's on my network the day that I took this screenshot, and you can see that the router has access for, now this is from my LAN side, so we don't see the outside side. From the LAN side, we can get web access, DNS access, ping address access. The devices that I have web access from, I showed you at the beginning, and that would be the printer, the Raspberry Pis, the Vonage system, and the two servers. And you can see you can ping the squeeze boxes and so on. So anyway, all in all, I hope you enjoyed the tour. I hope you picked up some information that you can use on your own network. This ASUS router has worked flawlessly for me. It has many more features than I need, probably more than you need. I should be able to use it for a long time. And with that in mind, I hope you enjoyed it. And you can write me and tell me about your network and ask me questions if you had it. So thanks for visiting today.